So now we are going to see the thermit welding process. Okay, so thermit welding process. What is thermit welding process? Principle. So thermit welding is a fusion welding process in which workpieces are joined by heat produced by exothermic reaction between aluminum and iron powder. So it is a mixture of aluminum and iron oxide powder, okay, mixed in the ratio of 1:3 by weight. So by weight 1 kg of aluminum powder, 3 kg of iron oxide powder, okay. So mixed in the crucible, okay. This mixture is called thermit mixture, okay. So it is ignited by another chemical, barium peroxide, okay. So this is the principle. So exothermic reaction, the heat is produced, the heat melt the iron and the molten iron is produced, and the molten iron is poured in the joint, and the joints are joined together, okay. So construction. So what is the construction in this? It uses refractory lined crucible. Okay, one crucible is there, so it is lined with refractory material, okay, like brick and other things, okay. Then sand mold, okay, a sand mold is made around the joint, okay. Then wax pattern, okay. Before filling the joint with molten metal, the joint is filled with wax pattern, okay. So for that wax pattern is used. Then sand plug, okay. So sand plug is used to plug the leakage out of molten metal, okay. Then heating gun. So heating gun is used to melt the wax pattern, okay. So this is a setup, okay. So this is a box like construction made between the joint. This is a two rails, okay. So in between rails there is a joint, okay. So in this joint the mold box is fixed, okay. So is pouring gate and heating gate and joint, slag basin, everything will be provided in the mold, okay. So what is the working? So thermit mixer is put into the crucible, okay. In the crucible, thermit mixer. What is thermit mixer? Thermit mixer is the aluminum powder and iron oxide powder, okay, mixed in the ratio of 1:3, okay, by weight. So thermit mixture is put in the crucible. Then second, the igniting powder, barium peroxide, is placed at the top, okay. At the top barium peroxide is provided, okay. Then the mixture is ignited by a flame, okay. A flame is used to ignite the mixer, okay. So due to this, liquid and slag is formed by the following chemical reaction, okay. So the following chemical reactions happened in the process, okay. So first what will happen? What you will put? You put aluminum powder and iron oxide powder, okay. So after putting the barium peroxide and igniting, what will happen? Fe is produced. So it will, aluminum oxide is formed as a slag, okay, it is removed. So how heat is produced? Here, okay. Aluminum combines with oxygen from the iron oxide. So from this oxygen is taken by the iron, okay. So the aluminum, okay, receive the oxygen, okay, combine with the oxygen and float like a slag, okay. The heat is used to melt the iron, okay. The chemical exothermic reaction, due to exothermic reaction, heat is produced. The heat is used to melt the iron, okay. The molten iron is poured into the joint, okay, mold joint, okay. What happened? Prior to the wax is filled in the joint, okay. So this is one piece and another piece. In between this there will be a gap, okay. This gap is filled initially by the wax, okay. Then what will happen? a sand mold is made around the joint. Okay, so after filling the wax pattern in the gap, wax in the gap, mold is made around the joint. Okay, then slag basin, pouring gate, heating gate, runner, everything is made in the mold. Okay, then what will happen? So before pouring the molten metal, the wax pattern is melted out using the heating gun. Okay, here heating gun, it will after removing the head, the heat is passed into the wax pattern mold. The wax is melted out. Okay, after removing the wax pattern, the sand plug is plugged into the gate, molten heating gate. Okay, then what will happen? Applying heat through the heating gate. After that, sand plug is used to plug the gate. After pouring the molten metal, after plugging, what will happen? From the crucible, and the molten metal is poured into the mold. Okay, so it will come this side and fill the gap. Okay, and then rise. Okay, this is a riser. Okay, so seeing the molten metal rising here, you can stop the pouring of metal. Okay. So after pouring the molten metal and solidification, you have to allow some time to solidify. Okay. So everything over, then the mold is destroyed and the joint is formed between two rails. Okay. So what are the other application? So it is used to weld broken crankshaft. Okay, broken crankshafts are also used to weld by this method. The weld non-ferrous metals. It is not only used for welding ferrous metal. It is non-ferrous metal also welded. Okay, to repair broken castings. So any casting can be broken. Casting can be welded by this method. So joining rail track. Okay, like this rail track. Okay, can be joined together. What are the advantage? No power is required. So electric power is not required. Okay, the large sections are joined. Okay, big junctions are joined by this method. Then remote location repair. Okay, you can take it to the remote area and repair can be done. Okay, it welds complex shapes. Any complex shape can be joined by this method. Okay, then quick heating. So by igniting the mixer, the molten metal is immediately produced within 30 seconds. Okay, 30 seconds to 1 minute. So what is the limitation? High fumes. Okay, by igniting there is a lot of fumes are produced. Okay, that is injurious to health. Then skilled operator is required to handle the molten metal and other thing. Skilled operator is required. Then high heat and distortion. Okay, so high heat is produced due to this distortion may be happen. Then danger of chemical reaction. Okay, so this heat is produced by chemical reaction. Okay, it should be carefully handled. Okay, so this is a thermit welding process. Okay, thank you.